Good afternoon, class. Today we're going to have, this is a pretty fun assignment. I like it because we get to the first of the graphing tools that we'll be using in this class. And this isn't an entry-level algebra class, so we make the assumption you've graphed before using a rectangular coordinate system, but just in case, I'm going to remind you what that is. And hold on, let me move that thing out of the way there. Okay, the rectangular coordinate system consists of two number lines, a vertical number line and a horizontal number line. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. Just like any number lines we were using in the last homework assignment, on the horizontal number line, to the right is positive. The point of intersection is 0. To the left is negative. Oh, what am I doing negative? What did I call out? What am I doing there? Those are positives. To the left is negative. I think I said it right. I don't know what I was writing down. On the vertical number line, up is positive. Down is negative. And is this looking familiar to y'all? The x-axis and the y-axis. We can refer to any spot on this flat surface. The flat surface I'm using is this sheet of paper, and that flat surface, by the way, is called a plane. We can refer to any spot on this plane using something called an ordered pair. Let's say this point right here, that little dot. Your movement always starts at the point of intersection. As a result, that point of intersection there is frequently called the origin, because that's where the movement originates. You would have to go 3 units to the right to get yourself lined up with that orange dot. That green dot. So we're going to say the x-coordinate is 3. You then have to move upward 2 units to actually get to that spot. So the y-coordinate is a positive 2. What about this spot here? You'd go to the left 1 unit to get lined up with that dot. So we'd say the x-coordinate is negative 1. You'd then have to count up 3 units in the positive direction, so the y-coordinate is positive 3. Realize negative 1, 3 is not the same thing as 3, negative 1. The order in which you write those numbers matters. 3, negative 1 would be right there. No, not right there. Right there. Goodness, what am I doing? That's just up there. Right 3, down 1. Why don't y'all tell me some coordinates, since I seem to be messing up so. How about this one right there? What would be the ordered pair representation for that green dot that I just wrote there? Okay, you'd go to the left 4, so I agree with the x-coordinate of negative 4, and you go down 3 units, I agree. The y-coordinate is negative 3. What about this one right there? Oh, And if you're thinking to yourself, Well, it could be negative 3.99999, and it would look like negative 4. So let's assume we're using integers. So the x-coordinate would be a 5, not a 5.00001, okay? So the x-coordinate's 5. What's the y-coordinate? Negative 4. Okay, the two number lines divide the plane into 4 distinct regions, and those regions are called quadrants. You start in the upper right-hand corner. This corner here is called quadrant 1, and we use a Roman numeral 1 to distinguish it from the numbers that are actually on the number line. Then we move counterclockwise, so we have quadrant 2, quadrant 3, and quadrant 4. Let's think about the signs in each quadrant. Okay, in this region right here, to get into quadrant 1, you'd have to go to the right and then up. That means the first coordinate must always be positive. What about that second coordinate, the y-coordinate? To get up here, will the y-coordinate be positive or negative? Positive, I agree. Now for quadrant 2, you have to go left and then up. So with that in mind, the first coordinate will be negative. I agree. You're going to the left, the negative numbers. The y-coordinate, positive because you're going up. Quadrant 3, what do we know about the signs? Negative, and I agree. You're going left and down. Quadrant 4, you'll go positive and negative. And now I want to look at some points that are actually on the axes. This point of intersection right there, the origin, you don't move left or right to get to it, so the x-coordinate is 0. What about the y-coordinate? 0 as well. 0, 0 corresponds to the origin. There's something that's interesting about the points that are on the two number lines. Let's look at this point right here. I guess I have a good black pen on. Let's just look right there. This point that's on the x-axis, we'd have to move 5 units to the right to get to that point. So positive 5. But what would the y-coordinate be? How much are you going to move up? 0. I agree. What about this point right here? What about that point? Give me that point as an ordered pair xy. Okay, you go left 4 and then up 0. Negative 4, 0. This is going to be important. Any point that's on the x-axis must have a y value of what? 0. If a point is on the x-axis, the y-coordinate will equal 0. And it should be obvious why that is. If it's anything other than 0, not on the y-axis, I said it correct. I wrote it correctly, but I didn't say it. If a point is on the x-axis, the y value is 0. And it should be obvious why. Because if that y-coordinate's anything other than 0, you're going to have to move up or down, so you wouldn't be on the x-axis. Let's apply that same logic to the points on the y-axis now. What about that point right there? How would we express this point as an ordered pair? Okay, you can't go left or right, so the x-coordinate is 0, but the y-coordinate is 4. I agree. I don't like that pen. What about this point right there? Okay, you can't go left, right. So I think we're beginning to see if a point is on the y-axis, the x-coordinate has to be 0. The y-coordinate is the number that's on the y-axis, so 0, -3. If a point is on the y-axis, the x value must be 0. And that sure is a messy graph, isn't it? Why don't we start using the graphing tools? Okay. We're going to graph several different types of shapes. We're going to graph lines, quadratics, cubics, square roots, absolute values. So, first thing, lines. A line, the equation of a line, doesn't have any exponents appearing on it. You have x's and y's. You may only have one x or one y, and we'll graph lines in more detail in another assignment. But for our purposes, a line can be written in the form ax plus by is equal to c. A line just has x and y. X and y are the variables. A, b, and c are numbers. X and y are the variables. How many points do you need in order to uniquely draw a line? I know I remember in high school I was always told, get 3 points. Make sure that you didn't mess up. But what's the minimum number of points you need to uniquely draw a line? 2 points. That's what this line tool is going to use. To graph a line, you need 2 points. And with that in mind, let's look at number 1. I hope I haven't been timed out. Okay. Give ordered pairs that are solutions and graph the equation. Notice this equation. Do you see an x squared or a square root of x? Do you see a y squared? All you see are x's. There's an x and a y. So this graph will be a line, and we'll need 2 ordered pairs to draw the line. Let me write this problem down. This is number 1. The equation is 4y equals 3x minus 12. They want us to complete the ordered pairs so that they're solutions to the given equation. Look at this XY table they're making. I say they're making because they haven't finished making it for us yet. And notice they have a 0 right there in the X column. Notice they have a 0 in the X column. This is saying, go to the equation, and where you see an x, replace it with the 0. They want us to find the y value. So, plugging in 0 for x, I'll write it right here. X is 0, so we have 4y equals 3 times 0 is, I'll write that out for this first one, minus 2. So we have 4y equals 3 times 0 is 0 minus 2. What's 0 minus 2? Negative 2. So we have 4y equals negative 2. What do we do to get y by itself? Divide by 4 to give us y equals negative 2 divided by 4. gives me a negative. Hey, we can reduce that 2/4. That reduces to what fraction? 1/2. I agree. Cancel a 2 above and below to get the ordered pair 0, negative 1/2. I wasn't expecting to get a fraction on this first one, but that's okay. Any questions on what we've done there? Now you come and you type in the y value is negative 1/2. Oh. What did I do wrong? 4y.
I said I was 12. You put 2 instead of 12.
I tell you. No. Okay, we're just going to start all over. This is just not my day, is it? Okay, this is number 1. 4y equals 3x minus, you're right, that's a 12. And so we have the x, y table. We're plugging in a 0. Wait a minute. Let me switch back. We're plugging in a 0. So we're going to have 4y equals 3 times 0 is 0 minus 12. So, yeah, the first problem in the assignment doesn't have a fraction popping up. That other one that where I miscopied and thought that was a 2, that's where we wound up with that fraction. This one here, we have 4y equals negative 12, divide by 4, and what is that giving us for y? Negative 3. So we have the ordered pair 0, negative 3. So come over here, and what is it, negative 3? What is this second row telling us to do? Look at that second row. Okay, they're saying put 0 in for y, and they want us to find x. So plugging in 0 for y, 4 times 0 is equal to 3x minus 12. 4 times 0 is 0 equals, oh, thank you. Okay, 4 times 0 is 0 equals 3x minus 12. Before we divide by 3, I think I would get that 3x by itself by doing what? Add 12. So we have a positive 12 equals 3x, and then dividing by 3, what are we getting for x? 12 divided by 3, I agree, is 4. So the second order pair is 4, 0. We said that this equation represents a line, so we only need 2 ordered pairs to draw the graph. Let's draw it freehand, and then I'll use the graphing tool, okay? So I'm going to draw myself a little XY grid. Drawing your XY grid, we're just freehanding it. We have 2 ordered pairs. The first ordered pair, 0, negative 3. 0, negative 3, that says go left, right. How many units do we go left, right? Left, right? X is 0, so we don't go left, right. We go down 3. for 0, -3. Remember we said that if the x-coordinate is 0, that means you're on the y-axis. What about the point 4, 0? We go right 4 and up 0 for my second point. The points where graphs cross the axes are referred to as intercepts. This green dot here is the x-intercept. This one here will be the y-intercept. Well, draw the line to the best of your ability. Connect those two dots with a slanted line. And as I said, this point here is the x-intercept. This point here is the y-intercept. And I don't know whether we'll be using that terminology today or not, but we'll be using it in future assignments. So I wanted to mention it. It's just the point where the graph passes through the respective axes. Let's draw this graph using the graphing tool. Okay. Oh, I didn't put another number there. What was it? 4? And realize I have this screen blown up, probably more than your own computer screen is. So what I'm going to do is I don't use the grid that's right here. I click and use the pop-out grid. First thing you got to do is let's choose it. Let's expand those instructions. Click the graph, choose a tool in the palette, and follow the instructions. Well, let's see. Click the graph and hold on. Let me see something. Come over here. Y'all tell me, we know the graph is going to be a line. One of these tools is a line tool. If you hover over it, object selection tool, you'll never use that. There shouldn't be a time when you're using the object selection tool. What about this thing beside it? If you hover there, line tool, it's hard for y'all to see because it's so blown up, but there's two blue dots there. That's how many dots we have. That's how many points we have. So you click the line tool. Now they want you to click the first point. It doesn't matter which point we plot first, 0, -3, or 4, 0. I think I'll plot the one that's that we found first, 0, -3. And notice how tight these spots are. It's sometimes hard to count. There'll be some where the grid is very tight. Here it's easier to count, 1, 2, 3. But notice, as I move my mouse around, right here in this little box, this little yellow box, you see how it's telling me where my pointer is? That makes it easy for me to tell if I'm at the right place. I want 0, -3. Is that the point? Yes. So click it. Now, they want you to click the second point. Well, the second point is 4, 0. Is that it? No, that's 3, -1. 4, 0, is that it?
Yes.
You click it. Then you have to click Save down here. It's going to transfer the graph back to the grid, the original grid. Check answer. And it's right. Any questions there? Next question. What sort of a figure is this going to be? Look at the equation. I don't see any x squares. I don't see any exponents. I don't see any square roots. I don't see track the variables and denominators. What sort of a figure is this going to be? Another line. I agree. Let me write it down. Number 2, 5x plus 4y equals 20. And let me make sure I've written it down correctly. Yes. Oh, wait, I better read what the instructions say to do. I wrote down the equation. Oh, they're not making a table of values this time. Look at what they've given us. They gave us an ordered pair with a 0 in front and the second number blank. What's that saying to do? Okay, it's just like with that table in the first problem. Plug in 0 for x. So we're plugging in. The x value is 0. 5 times 0 is 0 plus 4y is equal to 20. So we have 4y equals 20. What do I have to do? Divide by 4 to give us y equals 20 divided by 4 is 5. So the first point that we'll wind up plotting will be 0, 5. Well, that's the first one that we know we need to plot. So we come over here, 0, 5, and hey, what are they telling us to do here now? Okay, now they're saying let y be 0. So we're finding the x and y intercepts once again. So y is 0. That's a y, not an x. So y is 0. So we have 5x plus 4 times 0 is... Do you see why plugging in 0 is so nice? Because when you're multiplying, that term becomes 0, doesn't it? So really we just have 5x equals 20. What do? Divide by 5 to give us x equals 4. So the other ordered pair I found is 4, 0. And now they want us to draw the graph. I'm just going to graph it here under the, using the tool rather than wasting my paper drawing it. Okay. Once again, to use these graphing tools, you have to know what sort of a figure you're drawing the graph of. We know that this is a line. So we click the line tool, and then it says to plot the first point on your line. The order doesn't matter. I could put 0, 5 or 4, 0. With the line tool, you just plot 2 points. To illustrate, I'm going to put 4, 0 first. Is that 4, 0? No, it's 0, 4. Y'all see where I'm looking at. That makes it easy to spot the point you're going after. There's 4, 0. And now I need the other point. What was it? 0, 5. There it is. Once again, you have to save it so it transfers back to the original grid. And I imagine on most of y'all don't have it blown up the way I do, so I bet you see this whole grid. Am I right? If you're looking at your computer. So, check answer. Correct. Okay, wait a minute. Let me switch back to my work. We plugged in 0 for y, so we had 5x plus 4 times 0 is 0 equals 20. 5x plus 0 is just 5x. And what do we do to get rid of that 5 in front? Divide by 5. 20 divided by 5 gave us the x value. The x value was 4. Any other questions there?
do it on there specifically?
Yes.
Okay.
There's no time that I'll be graphing using a graphic calculator in this course. Now, you say, well, you have this little graphing calculator here. It's just for number crunching. That's all that we can get on there. If I could get a more basic calculator on here, I would. But this is what we're able to put on it. So, I think I saw a hand. Did I see a hand? No? Okay, so the first thing we've graphed are lines. The next thing we're going to graph will be the next shape. We'll have it be equations that are quadratics. A quadratic equation, you can't just have an x. If it's quadratic, what does it have to have in the equation? All those equations we solve by factoring and the quadratic formula, they don't just have an x. What do they have to be quadratic? Well, you're thinking about the coefficients, okay? Let's not think about that. There's got to be something attached to the x other than that. Maybe an x squared, that's it. So for quadratics, you can spot those because the equation has to have a variable square. The graph of a quadratic is a smooth U-shaped figure. It'll either open up or down. And we'll have an excellent assignment that delves into quadratics and the graphs of quadratics in more detail in a couple of weeks. But right now, all you need to know is that the equation for a quadratic has to have an x squared, and it's going to be either a U shape opening upward or downward. This smooth U-shaped figure is called a parabola. Parabola. And to illustrate, and they have a tool for graphing quadratics. For the equation y equals x squared minus 7, create a table with at least 3 ordered pairs. It's not going to be at least, it's exactly 3 ordered pairs, which is also at least, but they should just say create a table with 3 ordered pairs that are solutions and draw the graph. I like this, where they just give you all the numbers they want you to plug in, so you don't have to keep plug in one, type in the answer, then they give you the next one. Let's make the whole table right now. Let me write the problem down. This is number 3. Y equals x squared minus 7. And we have a table of values. Are we going to be plugging in numbers for y on this problem? We're only plugging in for x. In the lines, they would give you a number to plug in for x and then a number to plug in for y. Here, they're only giving you x values, and you'll be solving for y. So, let's get started. The first row that says plug in -2 for x. Oh, thank you. I tell you. So, when I'm sitting here thinking, oh, I can just do this by myself. I don't need Tony here. He does serve one purpose, okay? So, one definite purpose. Plug in -2. We get y equals. Replace the x with -2. Realize that -2 is being squared. Negative times negative is positive. 2 squared is. So 4 minus 7, that gives me a y value of -3. I agree. So there's my first ordered pair that I'm going to be plotting. -2, -3. What's the next number or question? Okay, what's the next number we're going to plug in for x? 0, okay. I keep thinking I hear people saying something. I mean, asking a question. So if I ask If you ask a question and I don't hear you, just say it louder. Plugging in 0, we get y equals 0 squared minus 7. Oh, this is nice. What's that going to give us for y? Negative 7. 0 squared is 0 minus 7 is negative 7. And finally, plugging in 2. I'm plugging in a positive 2. So that says y is equal to 2 squared minus 7. 2 squared is 4 minus 7. What's that going to give us? Negative 3. I agree. So we're going to go to the, well, first of all, let's punch in the numbers. We had a negative 3 and a negative 7 and another negative 3. And now it's time. Y'all see how I get that graph popped out? I click here where it says click to enlarge. And I'm going to have to choose my tool. Is this the tool I want? The line tool? No. Which one? It looks like one of those U-shaped figures. Can you? I was watching this old TV show yesterday, and the man had a bionic eye. He could see real small things from miles away. Can y'all read what that says? 3-point quadratic tool. Well, isn't that what we have? We have 3 points, and it's quadratic, that x squared. Now, in a few weeks, when we're doing that, the other assignment over quadratics, we'll have a much more advanced tool. But for here, all you have to do, you click the tool. It says plot the first point. It doesn't matter which point you plot. So I'm just going to go in the order. Negative 2, negative 3. See, it's sort of tight there, but looking up in that corner, is that it? Okay. Then what's the next point? 0, negative 7. Is that it? No, that's not it. Move over one more. Is that it? And the last point. Now notice at this point, notice what it's doing. As I move my cursor around, it's drawing every possible parabola that you could possibly have that contains those 2 points. But what's the third point? 2, negative 3, is that it? Notice how nice. When I was in school back in the olden days, a software, something like this, it was just science fiction. It was make-believe. And so I don't know how lucky y'all have it. Click Save. Oh, and look at transfers. Once again, this graph is bigger because the way I had the thing blown up to get the big instructions printed bigger. So I'll check my answer. Y'all think that's right? Yes, it is. And people say, oh, we don't use notes. I do use notes. Here's my notes. If you want to see my class notes, there they are. Okay? And so, number 7. Hold on. I'm going to get rid of that. I'm skipping from number 3 to number 7. We'll go back to the ones we skipped in a moment. Look at this. It says graph y equals 2x squared. This is number 7. Y equals 2x squared. And all it says is graph. That's all it says. They're not giving us numbers to plug in. That means we have to choose our own numbers. Well, I know that 10 squared is 100. I guess we're going to plug in 10. But remember, you're going to have to plot these ordered pairs. And I bet you anything. You see, you're not even typing in ordered pairs. when we click, it looks like everything has to fit between, what, -10 and +10? So for the numbers you choose, I recommend you use numbers close to 0. How about, we could use those same numbers that we used in the previous problem, number 3. We could use -2, 0, +2. I think I'll just use -1, 0, and +1. How does that sound? Okay. You know, if I ruled the world, that's one of the things I'd do. I'd outlaw the use of y's as variables. Anything that has a tail. Notice how that y tail, it comes down, it interferes. In algebra class, if I ruled the world, that's one of the things. You cannot use letters that have tails that go down into the work where you're writing beneath. What do you think? You think that's a good law? That'd be a good rule? Yeah. I'd be a very benevolent leader, you know. So, but say -1, 0, and +1. We could use X and W, or W and X. W doesn't go down underneath the line, right? So we could use a W and an X. Okay, I forgot what I'm doing. Oh, I'm plugging in, okay? First thing we'll do is plug in 1 for X. So we have y equals 2x squared. Replace the x with the -1. What's -1 times -1? Negative times negative is positive. 1 times 1 is 1, so we have a 2 times +1. What's that giving us? A y value of 2. So the first ordered pair we got is -1, 2. What's the next number we're going to plug in? 0. So we'll have y equals 2 times 0 squared. What's that going to give us? 0 squared is 0 times 2 is 0, so just a y equals 0. So there's the second point. What's the third number we're going to plug in? 1. Plugging in 1. We're going to have y equals 2 times 1 squared. 1 times 1 is, 1 times 2 is, to give us y equals 2. For my 3 ordered pairs. So, you'll notice as you move around, as you hover over the tools here in the graphing palette, you'll see it says what the tools are. Oh, that's a nice circle tool. We're not seeing circles today, but when we do, that thing is, it's an excellent circle tool. But we're using we have 3 points, and it's quadratic. So we click the 3-point quadratic tool. And what's the first order pair? -1, 2. Is that it? Yes. What's the next one? 0, 0. No, not there. Oops. There. Third one? 1, 2. But once again, notice what this is doing. It's drawing every parabola that could possibly exist passing through those 2 points. Okay. 1, 2. Is that what you said? Is that it? Yes, you're looking at the little ordered pair in the blue box? That's what I'm looking at. I'm not even looking at the grid as I'm moving that mouse around. So there. Don't you love how big? I remember when they changed the programming to make the dots bigger. Well, we had said they needed the dots. The dots should be bigger, okay? We didn't mean that much bigger, but that's one of the things that enough people complained about, so they made it. Do you see how huge those dots are? That looks really funny. Say, check. Any questions? Okay. Before I write number 6, we've graphed quadratics, and we said they have to have an x squared. They can't have a bigger exponent, but they've got to have the variable squared. The next shape we're going to look at is cubics. What exponent do you think will appear on a cubic? Right. It must have an exponent of 3. And there's no nice name for cubics. My brother calls them squigglies, but there's actually no. Parabolas, they have a nice name. Those U-shapes, quadratics have a nice name for their shapes. They're called parabolas. Cubics, no, they don't have a nice name for them. Tony calls them squigglies, but I guess that's as good a name as any. Let's look at number 6. And I know this is a cubic because what do I see in the equation? That 3, that x cubed. That's what says that it's a cubic. Let me write the equation down. This is number 6. The equation is y equals x cubed minus plus 4. X cubed plus 4. They want us to create a table. Hey, are we going to have to make up our own x values? No, they're giving us the x values. Let me write out this table. We're going to have to plug in -1, 0, 1, and 2. Realize that the y-coordinates for cubics will get extremely large for a relatively small x value. If you plug in a 5 for x, 5 cubed is 125. So even if you're only 5 units to the right on the x-axis, you'd have to be 125 plus 4. That's 129 units up. So when you're plotting a cubic, make sure you're going to have to use numbers that are close to 0, and that's what they gave us. So let me switch over to my paper. Here we go. Let's start off with x equals -1. X equals -1. That says y is equal to -1 cubed plus 4. Be careful with that -1 cubed. Negative times negative times negative is negative. Odd exponents don't change signs. And if you're punching that into your calculator, well, I guess in this case, if you didn't use the parentheses, you'd get it right just by luck, I suppose. -1 cubed plus 4. That gives us a -1 plus 4. That's a +3. So there's the first order pair. What about when we plug in 0? Plug in 0, that's pretty easy. 0 to any power is, plus 4 is 4, okay. I should say 0 to any power other than 0. 0 to the 0 is meaningless. Now let's plug in a +1. We get y equals 1 cubed plus 4. What's 1 times 1 times 1? 1 plus 4 gives me a y value of. Okay. And finally, plug in 2. I'm going to plug in 2 for x. So we have y equals 2 cubed plus 4. What's 2 cubed? 2 times 2 times 2. 8 plus 4 gives me and those of you punching it in, you'd punch in the number you're plugging in. When using an exponent key, it's always advisable to enclose the number in parentheses. That's x cubed plus 4, and it better give us 12. Sure enough, it does. Any questions there? Okay, so have that written down. So let's come over here. Let's punch in the answers. 3, 4, 5. Hey, these first 3 points, they look linear. As the x values increase by 1, the y values increase by 1. So these first 3 points, they could be points on a line. But then, once we get to 2, it's not going to increase to 6. It jumps to 12. And click. And go to the thing that looks like a squiggly. Is that it right there? Notice what, if you hover over it, I know that print is small, 4-point cubic tool. And that's what we have. We have an x cubed, so it's a cubic. And we have 4 ordered pairs, so I click that. And now it says plot the first point. The first point was -1, 3. Notice how the x values, or the x intervals are big, but notice the y intervals, they're changing the scale, because we're going to have to go up so far. -1, 3. What's the next one? 0, 4. Next. And look at that. They're on a line, aren't they? That's what I said. Those first 3 points right by 0, it looks like a line. But now as we move, it's drawing every possible cubic that has those 3 points. Well, what's the last one? 2. Is that it? Click. Notice it's certainly no longer linear. At 5, I said you'd be up at 129. And so these sides of cubics, you should expect the sides to be extremely steep. Save it. It transfers it back over here to the original grid. Check answer. Any questions there? So far, the order doesn't matter. For everything we've graphed, lines, quadratics, and cubics, the order in which you plot the points doesn't matter. There's one tool where the order in which you plot the points matters. The graphs of absolute value expressions. Absolute value, and you can spot an absolute value very easily. When you look at an equation, how do I know this is the graph of an absolute value expression? Those lines there, don't you see the absolute value bars? So, before we graph them, we need to discuss, because this is the one tool where the order in which you plot the points makes a difference. Absolute values. You expect the graph to be, we're only going to have the absolute value expressions where there's a linear expression on the inside, like x plus 5. I remember solving some absolute value quadratic equations. Now we're not going to see those in terms of graphing. So the graph of an absolute value expression will be a V, not to be confused with the U. A U is a parabola. Do y'all agree what I mean by U and a V? A V has a sharp point, correct? A U has that smooth turnaround. An absolute value has a sharp point where it changes directions, there or there. For an absolute value and a parabola, the point where the graph changes directions is called the vertex, and we'll have a nice little formula that we can use to determine the vertex of a parabola when we get to that in a couple of weeks. But for now, all you need to know is that that sharp point where the graph changes directions is called the vertex. And to determine where the vertex occurs, you set the stuff inside the absolute value bars equal to 0. Ask yourself, look at this number, whatever it is, 8. What number would you have to plug in there? Don't write this down. What number would that x have to be to make the inside stuff 0? -5. So the vertex occurs at -5. So that's what I'm trying to say here. I'm going to write this out. The vertex occurs when, I won't say the stuff inside the absolute value bars, I'll say the expression inside the absolute value bars is equal to 0. When using the absolute value graphing tool, the first thing they're going to tell you to do is plot the vertex. Even if that's not the point that you find first, the first thing you'll have to plot will be the vertex. And I'm going to say, plot vertex first when graphing. You think I can get that thing on there? Yeah. I'm getting hot up here. Okay. Number 8. Let me write the problem down. Y equals the absolute value of x plus 5. You know, we should have done I hate to do this. I think we should do number 5 is another absolute value, but they give you the x values they want you to use. So should we do that one first? Yes, where they're choosing the x values for you. Yeah. I'm not going to, you'll notice, I've already written down number 8. I'm not going to erase it because it's ink. I can't erase it. What I'm going to do is I'm just going to go to the next page and write down number 5. Oh, I forgot what number 5 is. Well, I didn't look at it, so let's look at it. Here's the one. So just skip a little space if you've already written down number 8. Skip a little space. This isn't the same one as number 8, is it? Okay. It's not exactly the same. It just looked the same. It's not exactly the same. This is a y equals x minus 5. And you'll notice here they're going to give us the numbers they want us to plug in. It looks like the first number they're going to want us to plug in is -5. So We're making our little table of values. We're plugging in -5 for x. Let's plug in -5. So we have y equals the absolute value of -5 minus 5. What's -5 minus 5? Be careful, don't say 0. That's a -10. But what do you have to do to that -10?
Make it positive.
Okay, the absolute value of -10 is a positive 10. Good. So we have the first order pair, -5, 10. Let's come over here. -5, 10. Any questions there? Once you plug in the x value and simplify, you have to remember to take the absolute value. And of course the common mistake is people use -10. They forget about that absolute value bars. Now they're going to give us another number. The next number is a +5. So let's plug in a +5. So we have y equals, it's the absolute value of +5 minus 5. Now, oh, you can't see what I'm writing. Thank you. There. Next is +5. We get a +5 minus 5 inside the absolute value bars. What's that going to give us? The absolute value of 0 is? So, remember we said that the vertex occurs when the inside stuff is equal to 0. So, this point we just found, that's the vertex. I'm telling you right now, that's going to be the point they want you to plot first. So make a note that that's the vertex. Let's see there, plug in my 0. I'm typing my 0. They want to, hey, they have another line here. What do they want us to do? 13 for x, so we're plugging in 13 for x. So we have what? X equals 13, so y is equal to the absolute value of 13 minus 5, I agree. 13 minus 5 is 8. And what's the absolute value of 8? It's still 8. So y equals 8. Any questions on our logic there? So we have 3 ordered pairs. We're only going to have to use 2 of them with this new graphing tool. So everyone written this stuff down. Here's where I plugged in 13. There's where I plugged in -5, and there's where I plugged in +5. So, coming over here, I have to plug in type in my 8. And now, click. Look at that. Oh yeah. We're going to have to, I'll definitely be looking up here to see the ordered pairs. So, there's one shape that looks like a V, and it's hard to tell, but there's only 2 blue dots on there. If you hover over this V, y'all see what it says? Absolute value tool. There are only 2 blue dots, so we're only going to be using 2 points to draw the graph. You click the absolute value tool, Click the graph to plot the plot the vertex. That's 5, 0. Oops, that's not it. Is that it? There's the vertex. Now it says click the graph to plot another point. So, which other point? Notice as I move around my mouse, notice it's drawing every possible absolute value expression with a vertex of 5, 0. We only need one other point. It's taking advantage of the symmetry. When it fills in the point on the right, it's also drawing in the left and vice versa. So, which point do y'all want to use? Negative 5, 10 or 13, 8? You'll still get the same graph regardless. Negative 5, 10. Is that a positive 10? This thing, is that it? So I'll click it, save it to transfer it back to this big grid here. Check my answer. For absolute value expressions, the first point you must plot is the vertex. The vertex occurs when the inside stuff is equal to 0. When is that inside stuff equal to 0? When x is positive 5, there it is. You have to plug in that vertex value in order to as one of the points when you're making your table. And with that in mind, let's go back to that number 8. There. Here's my logic. I'm asking myself, when does the inside stuff equal 0? When does x plus 5 equal 0? And we get when x is equal to negative 5. So I have a table of values. Oh, number 5, they had us making they had 3 ordered pairs. We don't need 3 ordered pairs. We have to use negative 5. And what's that going to give us for y? It should be 0. I mean, it should be obvious. Negative 5 plus 5 is, okay, and the absolute value is 0 is 0. Now we need another number. We need another number to plug in for x. You could use 50 if you wanted, but I bet you that the grid won't let you do that. I bet you if you go to number 8, looks like they're on number 8, the graph is only letting us go up to 10. I think it only goes 10 units in each direction. Choose something that's real close to negative 5. How about negative 3? I could use negative 4, but it's going to be packed in so tightly there. I think I'll use negative 3. Now plug in negative 3 for x. So I'm plugging in negative 3. Negative 3. So we have y equals the absolute value of negative 3 plus 5. Negative 3 plus 5 is 2. The absolute value of 2 is 2. Give us y equals positive 2. Any questions there? We don't need 3 points for the absolute value tool. Number 5, they had us getting 3 points, but we didn't need it. So I click my absolute value tool, and what's the first point I plot? Negative 5, 0. There. And now we found another point. What was the other point? Negative 3, 2. Is that it? Save it. check answer. In today's assignment, the only graph where the order in which you plot the points matters is this absolute, the absolute value expressions. The lines, quadratics, you just plot them in the order in which they fall out in the table. But for absolute values, you must plot the vertex first. Any questions there? So we have 1, 2, 3. We have 4 really nice graphing tools in this section. Lines, quadratics, cubics, absolute values. There's something else they want us to graph in here, square roots. But there's not a square root tool built into this course. So for those problems, they'll be handled the old-fashioned way, multiple choice. So, let's see, square roots. That was number 4. You know something? Maybe it'd be nice if I'd been numbering along the way to indicate what we were graphing. Would I underline it, highlight it, or something? Let's see. We graphed lines. I'm going to call that A. And then we graphed quadratics, B. I'm just doing this for me. C for cubics. D for absolute values. And now we're ready for E. Maybe I should have used Roman numerals. Maybe that would have been better. For square roots, they're not going to give you the numbers to plug in. It's up to you which ones to plug in. But here's my advice to you. An absolute value, the first thing you do is you find where is the stuff inside the absolute value equal to 0? Well, I'd ask myself, when is the stuff under the square root equal to 0? Because you have to avoid imaginary y values. That means you can't get a negative number under a square root. Lily, earlier in that problem, that other assignment, that square root of -9, that's the thing you don't want, a negative under the square root. Because it's imaginary, it can't be labeled on a number line. And my recommendation, set the thing, I won't say thing, I'll say set expression under the square root equal to 0. And that'll give you a starting point. That's where the graph is going to start. It'll start and either go to the left or it'll go to the right. But that's going to be the starting point. And it sounds a lot worse than it is. Okay, so let's look at number 4. Number 4. We decided, when I'm sitting up here thinking, I can do this all by myself. I don't need Tony here. We've discovered you do contribute one thing. You remember to switch it. Oh, okay. I'm here halfway through with the problem. But I didn't get that far, did I? I just get started and y'all call out. But yeah, that's one of those things, our indisputable contribution to each other than the colorful repartee. Where's my cup? Oh, I'm getting thirsty. All this talking. Okay, so let's switch over. No, let's not look at those. Okay. We're going to draw the graph, then we'll look at the pictures. Otherwise, they might figure it out before we've actually plotted any points. We want to graph y equals the square root of x minus 1. The first thing I do is I ask myself, when is the stuff under the square root equal to 0? When does x minus 1 equal 0? That's when x is equal to 1. Okay, that's going to be the starting point on the graph. One side of 1 on the x-axis will give us real numbers that we can plot. The other side of 1 will give imaginary numbers. We're going to have to plot 1. Well, let's choose some numbers on either side of 1. Suppose we tried to use 0 and 2. Let's fill in 1 first. 1 minus 1 is, and the square root of 0 is 0. Okay. Let's try plugging in 0. X is equal to 0. We get y equals the square root of 0 minus 1. What's 0 minus 1? That's a negative 1. What's the square root of negative 1? That is an imaginary number. That's what we don't want. We can't use 0. That would be I, 1i. We don't want the square root of a negative number. You can plug in any other number you want to as long as you don't get a negative number. And if you use negative 1, negative 2, negative 50, all of those would give you imaginary numbers. So it isn't to the left that we're going to be graphing. It looks like we're to the right of 1. Plug in 2. If you plug in 2, are you going to get an imaginary number? No. Y equals the square root of 2 minus 1. That's the square root of 1, which is 1. So we're going to the right. How about if we plug in a few other numbers, okay? Suppose we plugged in a 5. If we plug in 5, are we going to get an imaginary number?
Now here's a good question. Why did he choose 5 rather than 3 or 4? Well, if you plugged a 3 or a 4 in for x, I think you'd wind up with a decimal number, wouldn't he?
3 minus 1 would be a 2. The square root of 2, is that an integer? It's a 1.4 something or another if you punch it into your calculator. I'm trying to choose a number that will give me a perfect square. So 5 minus 1. Let's see. We're using x equals 5. Y is equal to the square root of 5 minus 1. What's 5 minus 1? The square root of 4 is 2. And with that, I think we have enough points to draw a very good graph. And I'm not going to draw it real big either. Move that cursor. I'm going to draw it right out here.
I'll move the cursor around as a program. I was assuming you would draw it out.
Okay. Notice there's no sign in front of this thing. These y values are all going to be positive. So there's not going to be, I don't expect any of the graph to lie below the x-axis. Here's my xy grid. There. We have 3 ordered pairs. Wait a minute.
I think you need one more mark here.
No.
1, 2, 3, 4.
Oh, you're right. Right there. There, that's 5. Good. Okay, let's get started. We start at the starting point, 1, 0. Tell me where that's located. Is it located right here? No, you go to the right 1 and then up 0. There. And then the next point, 2, 1. You go to the right 2, up 1, 5, 2. We go to the right 5 and up 2,
There you have it.
and it's increasing. By that I mean it's rising from left to right, but it's this gradual increase. If we went out 101 units, if x were 101, we'd be way over here. 101 minus 1 is 100. The square root of 100 is 10. So if we went way out here on the x-axis, we'd still only be up about that much. So it's rising very slowly. There's a gradual increase. Any questions on my logic? Notice there's a starting point, but no stopping point. And there's no portion of the graph over here to the left of 1. Any questions there?
None of it below the x-axis.
And none below the x-axis. So now let's look and see which one. Blow up B. Blow up response B. I think we can easily discard B, right? What about
Just
C?
by the fact 1, 0 is not on this graph. That first point, 1, 0 is not on there.
Yes, it is.
Oh, it is?
It's incrementing in units of 2. Right? 1.
You're right, it is. Okay, well, heck, you're right.
But it's a parabola, and parabolas have x squares. This equation doesn't have an x square, so it's clearly not that one.
Give me another one that it's not.
D.
D.
Blow it up on.
Yeah. See, that's another parabola.
Certainly not that one. So it's either A or C. Blow up C. Is that it? Mm-mm. I think it's got to be A.
Yeah, it's A. It's got to be. Right, 1 is, it is incrementing by 2. Right, 1 up 0. Then
Right 2 up 1.
right 2 up 1.
And then 5, 2.
Okay, 2, 4, 5 is right here. Up 2. Again, each mark is incrementing by 2. So every square root function graph is going to have that basic shape where it starts. I think your graph actually looks better than those. It starts at one end and goes off slowly in one direction. Okay? It's not going this way because you can't have any x's smaller than 1.
So once you find where the thing under there is equal to 0, one side of it's going to have the graph, the other side will be producing imaginary numbers, which you can't draw. Okay?
So which one did we decide it was? A?
Mm-hmm.
Okay. So have you done all the graphing?
I think so.
Now they want to form some formulas.
Yeah. How about you take over with these formulas?
Okay.
Let my voice rest a little bit.
We haven't had a lot of formulas this semester, have we?
The quadratic formula.
Yeah. And
I guess we haven't. The distance and midpoint
yeah,
formulas.
that we're about to. Go ahead and let them see the problem.
Oh, you want them to see the problem?
Problem 9. 9 and 10 are distance midpoint. I don't think I'm going to define the word distance. Okay? I think most of y'all know what the word distance means. Midpoint is the point that lies right in the middle. So what we're going to have here, and I'm about to state 2 formulas. We're going to have a formula that calculates the distance between 2 points. Like on this problem right here, if we plotted both of those points and connected them with a connected them with a line, what's the distance between them? And what point lies right midway between them? So I like to do this. Here's what I like to do. Okay. I'm going to say, before you state your formula, okay? Before you state your formula, okay.
Here's a line segment. There's a line segment. Point A and point B. Say you take a measuring tape and you start it there. That's an old-fashioned thing, tool that carpenters use, a measuring tape. You put it here, or a ruler, and you stretch it over here. That length, the length of that segment is the distance.
Wow, so you really are defining the word distance to a class
Full of adults.
of adults. Okay. Now tell them what middle means, Tim. Point lies right in the middle. Go ahead.
Okay,
Tim.
look at the line segment.
Eyeballing which point looks like it's right in the middle.
Where does it look like? Right out, maybe right there? That point right there, does that look like it's in the middle? It breaks it in half, the line segment in half. I mean, when you put it like that, you make it seem like, it makes it seem like I'm doing something very stupid.
Well,
Okay,
we could have already
there.
stated that formula.
You state that for me.
Okay.
then.
We're going to need two ordered pairs. And so I'm going to say given. Now, ordered pairs are always in the form X, Y, but there's something wrong with how I'm writing this right here. I can't just use X, Y for both of the ordered pairs, because how do you know, how do you distinguish them? So I'm going to use a subscript. These are not exponents I'm writing.
The X in the first ordered pair, the Y in the first ordered
First
pair.
X, first Y. What do you think I'm going to call this one right here?
Okay, the
Subscript
second X.
2. Yeah. Remember, ordered pairs are always X, Y, X, Y. Sometimes I'll see students write the formula beautifully, but in the ordered pairs, they'll go X1, X2. No, no, no. If you do that, you're going to mess it up. So here's the formula for calculating this mysterious word called distance. Let me get it all. It's first X. No, second X minus first X, all squared, plus second Y minus first Y squared. So you're going second X minus first X, we'll square it, plus second Y minus first Y, square it, and take the square root. So that's the distance formula. Now, I'm going to go ahead and state the midpoint formula. If I told you to average two numbers, if I gave you two numbers and said to average them, could y'all tell me how to average two numbers? What would I need to do? Add them up and divide by 2. That's how you're going to get the midpoint. You average the x's and then average the y's. And by average, I can't just leave it like that in words. We're going to write out a formula for how to average two numbers. Well, to average the x's, you would add them together, so that'll be x1 plus x2, and then divide by 2. Isn't that how you average two numbers? And then the same thing with the y's. Average the y's by saying first y plus second y, all divided by 2. So that midpoint formula will tell you that ordered pair that's right in between the two given points. Let's see if we can do problem number 9. I'll keep that those formulas right there. Wait, yeah, this is number 9. It says, for the point P, there's a lot of words and stuff there that we don't really need. We just need the 2 ordered pairs. 11, comma, negative 17. And the second ordered pair is 18, comma, negative 12. So 11, negative 17, 18, negative 12. Okay. And what does it say? Oh, distance is what we're doing first. Okay. Well, first of all, let's label the ordered pairs. This is where I say that sometimes students make mistakes because they'll go x1, x2. No, no, no. These are ordered pairs. Ordered pairs are always are always xy. First x, first y, second x, second y. I'm just writing down the distance formula, but I'm about to plug in place of x2.
What's he going to put there in place of x2?
What am I going to put right here?
18. I agree.
Minus 11. And then over here, negative 12. Okay, minus y1 is a negative 17. Be very careful. This purple minus is in the formula. The black minus I'm about to write is from the negative 17.
As I look at that, it all looks black to me.
Oh no. Can y'all tell? What's about to happen right here with this minus and negative? It's going to have to become a plus. Okay, that minus. Y'all see why we have minus negative, or why I'm changing it to plus? It's y2 minus y1. So negative 12 minus a negative 17. That's why we're getting the 2 negatives there. If you're wondering, well, wait, we don't have 2 negatives here. No, we don't. 18 minus x1 is a positive 11. Do y'all follow that? And now let's simplify. 18 minus 11, is that 7? So we have 7 squared plus, what about over here? Negative 12 plus 17. Is that going to be a 5? Squared. So, continuing to simplify, the 7 squared is 49. 5 squared is 25. I was about to say 64 is under there, but no, it isn't. What's under here?
74.
It's 74. I was thinking it was going to be something that would simplify real nice, but I was wrong.
Is 74 a perfect square?
No.
Is there a perfect square that divides evenly into it? It's a 2 and a 37. Yeah, 37 and 2 are
what
prime.
calculator one of those things wants where you can punch and square root of 74 and it'll simplify it? Or does it just give it as a decimal?
The square root of 74 cannot be reduced.
Yeah, the square root of 74 can't be reduced. There's some calculators where you,
It is 74.
Oh, okay. So yours is so it can't be reduced. But yours is one that'll if I punch in square root of 50, it'll say 5 square root of 2.
Mm-hmm.
Oh, that's a nice calculator there. Okay.
Go ahead and find the midpoint.
Yeah.
And then I'll
okay.
type in the final answer.
So that's the distance. Now we'll do the midpoint. I'm going to draw my parentheses.
I would figure. Okay, y'all tell me what's going to go here where I'm pointing. Okay, so it's x1, 11. We're averaging 11 and 18. We're asking ourselves, what number is midway between 11 and 18 on the x-axis? What's going to go here? Negative 17 plus negative 12. What number's midway between negative 17 and negative 12 on the y-axis?
Now, let's see, 11 plus 18, is that going to be a 29 on top? 29 over 2. We'll just leave it like that. We don't write it as 14.5. Pearson doesn't usually like decimals unless it's
dollars and cents.
Yeah, and what's this one going to be here? Is this going to be a negative 29 over 2? Oh, that's just, okay. It's just a freak coincidence. Don't decide, oh, it's always going to be the same number, one positive, one negative. No, it isn't. That's just a freak coincidence. Okay. So 14 and a half to the right and down 14 and a half. That would be the ordered pair that's right between 11, negative 17, and 18, negative 12. Here's the ordered pair that lies right between them. And, okay,
so the distance, the square root of 74.
Punch it in. Oh, no. Press. 29 over 2, comma, negative 29 over 2. And that is wrong. Why?
Make sure you've enclosed your answer in parentheses. We didn't have it enclosed in parentheses.
And you think to yourself, oh, no big deal. If I make that mistake, it'll warn me. Yeah, but on a test, it won't warn you. Okay?
I'll just count it wrong.
Now let's do another one of those. Number 10. Mm-hmm. 9 and 10 are both the same problem type.
Mm-hmm.
Okay.
Find the midpoint and the distance.
So 14, negative 2. And is that a 21 and 3? So go ahead and, but let me make sure I don't miscopy it. 14, negative 2, 21, 3. Okay. I'll call it x1, y1. So see, if you had said x1, x2, you're going to mess up on it. Okay? Make sure you're going x, y. And I think I'm going to go ahead and recopy or write down that distance formula. It's x2 minus x1 squared plus y2 minus y1 squared, all under that square root symbol. So okay, so get started. x2 minus x1. So it's going to be 21. Oh. Minus 14 squared plus, what am I going to write here? 3 minus a negative 2. So that's going to become a 3 plus 2 right there, isn't it? And in case you're wondering why seem distracted all of a sudden. It just dawned on me, I think we're going to get the same answer on this one. Aren't we? The 21 minus 14 is...
It looks like 147.
Oh.
Mark out your squiggly after the 4. I'll see what I'm talking about there.
Yeah. So 7 squared. Am I right? It's going to give me that same 74. Plus 5 squared. I think it's all exactly the same as what I have right here. Okay, well, it won't always work out like that, but it did this time.
Another coincidence.
Yeah, 49 plus 25. So it's a square root of 74 again. But surely we'll get a different answer for the midpoint. Out of room. So
you average the x coordinates, you average the y coordinates.
I'll state it formally. x1 plus x2 divided by 2, y1 plus y2 divided by 2. And we better not get 29 over 2 for these. Just because, surely
But
not.
we could, but we don't.
Yeah. So it's, oops. So it's x1, 14, plus 21, and then negative 2 plus 3. Y'all hear that? I agree. 35 over 2, comma, what? 1 over 2. So 35 over 2, that's 17 and a half. So the point that lies right between 14, negative 2, and 21, 3 would be, I think I said the wrong thing. I think I said 17 and, is that what I said? Oh, 17 and a half. Right 17 and a half, up a half. So there's your...
And tell them, circle this one at that midpoint there too.
Oh, I'd had that circled it. Yeah, okay.
Feels incomplete without boxing in that final answer.
Right.
Okay, so the square root is 74 and 35 halves, comma, 1 half. So going through writing down, I'm switching over. It was really strange that wound up being another 74 under there.
Yeah, if you look at the videos, you'll see it doesn't usually happen like that.
35 over 2.
I wonder if
out
you
of
put
the
the comma right there.
I
If you
bet.
left it down there, will it
Let's
take
see.
it?
And what did you say, 1 over 2? I thought it was negative 1 over 2.
Nope.
What do y'all think? I shouldn't have that comma down there in the denominator. Let's see.
Oh,
Yeah,
it took
they
it.
took it.
Okay. Sometimes they take it, sometimes they don't.
But
That's bad
generally,
on tests.
generally, it's a bad practice to put it down there because if sometimes they take it and sometimes they don't, then suppose it's a test question. You don't get to redo it and correct the typing. So make a habit. Don't put commas in denominators.
Any questions there? That ends this
And at number 11.
number 11. Next 5, or do you remember that? When is this undefined?
When a fraction's undefined?
What makes that first fraction undefined? If x is what? What number do we not want in the bottom of a fraction?
I couldn't hear you.
Yes.
Okay, you don't want a denominator of 0, so x can't equal 1. Y'all remember these? You're not solving them. You're just going through asking yourselves what numbers can't be solutions.
For the second fraction, what would it be? What would make that 0 down there? Negative 3.
3.
Go ahead and get it right. Type in 1 and negative 3. If you remember doing these as homework, that last one, the one with the x squared factors, is x minus 1, x plus 3. So there's only 2 numbers there. Not solutions, just
Numbers that can't possibly be
solutions. And I think we've talked enough here. Go ahead and cut that off.
Okay, any questions you want recorded? No? Okay, I'm going to